and convert them into 3D, three-dimension models. It's designed to be intuitive and fast, even for users without technical backgrounds. Next is the Light Compass, which helps define the building's orientation and location. It uses mobile sensors and APIs to retrieve weather data, which is critical for accurate energy simulations. Then we have GESS, the G Plus simulation services. This tool runs Energy Plus simulation online, using the data collected from the sketch and the compass. It outputs predictions for gas and electricity consumptions, heating and cooling loads, and CO2 emissions. To get further, we use GEA, the G Plus Energy Analyzer. It performs sensitivity analysis and optimizations, helping users compare different retrofit scenarios and choose the most effective one. All of this is tied together with Flask Web API, which acts as a gateway between AI models and the web interface. We also use TensorFlow Lite to support mobile development, making the tools accessible on smartphones and tablets. Together, these tools form complete ecosystem for smart, scalable, and user-friendly engagement assessment. Again, as we can say from here, alongside the technical innovation, Ecrofit places a strong, emphasis on capacity building, ensuring that these tools we've developed could be adopted and used effectively by professionals in the field. We've designed a CPD, which is continuing professional development, a CPD certified training course. I create the content from scratch, data analytics for sustainability. I delivered over three morning and tooling to 12 hours. The course was aimed at SMEs working in architecture, construction engineers, and property-related sectors. The training covered key topics such as data processing, machine learning fundamentals, and energy analytics. Participants learn how to apply these techniques to improve business performance and support sustainability goals. Importantly, the course was fully funded and for eligible SMEs in Birmingham, and thanks to support from the European Regional Development Fund as well. Delivered online by Birmingham City University, the course was designed to be accessible, practical, and immediately applicable. It helped demystify AI and data analytics for professionals who may, not have a technical background, giving them the confidence to engage with the smart tools and retrofit strategies. The feedback was overwhelmingly positive, with many participants reporting increased awareness of how data can drive the sustainability and cost savings. The training component was essential to Equifit missions, not just building tools, but building skills and confident in using them. As you can say, this is the acknowledgement and the award about the award. Um, you know, so from this is the as you can see, and the right and built environment and construction project was, won the technology award. So Ecofit actually has delivered tangible outcomes, beyond the academic research. First, we created and released a data set of 5,000 annotated floor plans tailored for energy performance. The data set is publicly available under the common license, making it a valuable resource for researchers and practitioners. Our active learning model significantly improved the speed and accuracy of floor plan annotations. What needs to take hours manually can now be done in a minute with high precisions. The integration of AI and simulation tools enables automated 3D models generation, removing the need for expert CAD and skills. This opens the door for broader adoption among SMEs and non-specialists. Throughout our CPD training, we've empowered dozens of professionals to use data analytics and machine learning in their sustainability efforts. Many participants have gone on to apply these skills in real projects. So Ecrofit has also received industry recognition, including Technology Award for innovations in the built environment. So this reflects the project's relevance and impact in understanding real-world challenges. Ultimately, Ecrofit has shown that AI can be a powerful enabler for sustainable transformations when paired with thoughtful design, training, and collaborations. So future vision from now, as we look ahead, Ecrofit is evolving from a research project into a scalable platform for smart energy assessment and retrofitting. One of our goals now is to develop a universal APIs that can convert 2D flow plans into 3D models using a standard format like DFX, XML, STL, and so on and so forth, and others. This will allow the seamless integration with existing 3D software and rendering tools. Beyond energy assessment, we see opportunities to expand into interior design, property marketing, and visual viewing, where AI-generated models can enhance user experience and decision making. We are also exploring the integration of expert systems that can recommend retrofitting strategies based on building type, locations, and energy goals. This would make the platform even more actionable for professionals. One of the technical side, we aim to improve mobile development and deployment and enable real-time simulations, making it easier for assessors to work on site using a smartphone or tablets. Finally, we are actively seeking cooperation with industry and government bodies to scale adoption by aligning with policy initiatives and sustainability targets. Ecrofit at the moment can play a key role in national and recognition and regional retrofit programs. So the future for Ecrofit is about scaling impact, making a smart energy assessment accessible, efficient, and transformative across sectors. So energy projects, this is the learned lessons, brings its own set of challenges, and Ecrofit was no exceptions. One of the first, hurdles we faced were the manual annotations of flow plans. While active learning significantly reduced the workload, we found that expert validation was still essential to ensure accuracy. So this addressed a layer of complexity, but was crucial for building a reliable data set. Another challenge was balancing model performance with usability. We had to ensure that our tools were not only accurate, but also intuitive for users with our technical backgrounds. This meant simplifying interfaces and providing clear guidance throughout the workflow. A key insight was the value of interdisciplinary collaboration. Ecrofit brought together experts in AI, constructions, sustainability, and educations. This diversity was vital in designing tools that were both technical, sound, and practical useful. We also learned that training is just as important as technology. Even the best tools want the best tools. So finally now, thank you all for your attentions and engagement. To summarize, Ecrofit demonstrated how AI and data analytics can revolutionize the energy assessment and retrofitting, making it faster and more accurate and more accessible. By combining smart tools with targeted training, we've created a platform that empowers professionals and SMEs to contribute meaningfully to net zero goals. We've also learned that collaboration across disciplines, sectors, and institutions is essential for sustainable innovations. I hope this talk has sparked ideas of how you might apply these lessons in your own work, whether in research, industry, or policy. Thank you very much for your attentions.
Uh, Thank you, Dr. Noor Sabri, for delivering us such enlightening talk on AI power, reprofiting, and smart energy transformations.
Thank
We
you.
have learned active learning and AI pipelines, smart tools developed by the Acrofit and CBD training. You are doing a wonderful job. Thank
Thank
you.
you very much.
Yeah, your innovative work and clear presentation inspired our participants and added a great value for this session. We are deeply appreciate your times and contributions.
Thank you very much. Have a nice day. Thank you.
Thank you, Doctor.
the solution oriented approach that we need to address in this coming time. I would like to start my talk with Antonio, who is UN Secretary General, and his words say that climate change is the defining issue of our time. And every day we fail to act in a day that we step a little closer towards the fate that none of us wants. A fate that will resonate through generations in the damage done to humankind and life on earth. And this kind of damage will not be reversible. So we need to act today to address these kind of challenges. I would like to start that globally, top 5 countries are contributing in carbon dioxide emissions. And among them, if you focus, China and India are the biggest countries that are attached boundary-wise to Pakistan, and they are contributing 60% of greenhouse gases. Compared to that, there are 20 different countries, and Pakistan is none of them, who are contributing up to 76% of global greenhouse gas emissions. Where does Pakistan lie? Pakistan is only contributing 3.8% along with other developing countries. So what has been happening to Pakistan right now is that Pakistan is polluted and is facing climate challenges because of our two biggest neighbors, China and India. But all other countries that are not contributing to that extent are also seeing the same fate as they are. Transport and energy nexus is very important to understand because transport sector in any country consumes massive energy. And our goal should be to introduce the smarter, cleaner and sustainable transportation system. Now, how smarter transport systems can directly lower the energy use and carbon emissions? And where Pakistan have to start with. So this presentation covers both the technical as well as the system level approaches that we need to address today to combat this climate change and to combat the energy efficiency problems. If you see this, globally, transportation sector is contributing 71.7%, more than 75% of total energy efficient problems in the whole region globally. But out of that, 71.7% contribution is of road transport. If we again check into the description of that, 60% is done by cars, 27% by the fleet, trucks, etc., and 1.3% for the motorcycles. And this figure is a global figure. Rest of like other modes of transportation, civil aviation, water, navigation, railway, etc., their contribution is very small. So what does it show? That they are sustainable modes compared to the road transport. Now the challenge that whole world is facing with respect to transport's climate footprint is that carbon dioxide is the biggest emitter. And if we combine transportation with it, then the road vehicles are contributing 75% of that. Cars, motorcycles, trucks, rickshaws, chingchis, buses. You see all of these vehicles on your road every day, and they are contributing up to 75%. High consumption of energy. Even if other sectors we consider like industry, power, we clean them, we control them, but still transportation sector is still blocking the climate action targets, the global sustainable development goals that we were supposed to achieve right now. If I show you European facts and figures, so from 1990 till today, domestic transportation is still the topmost cause that is affecting the energy conservation. So from where we start, the very first thing is that we need to understand the modal energy intensity. And by this modal energy, I mean to say the modes of different transportation, railways, roads, aviation, etc. So these different modes of transport consume energy at different rates. For example, cars 1.6 to 1.8 megajoule per passenger kilometer. Following the buses and the rails, freight is also consuming lots of energy. For example, a truck is consuming 2.7 megajoule per ton kilometers. Same is for the freight, railway freight, etc. So trains and buses, they move more people and more goods per unit of energy compared to cars or trucks. So why don't we think about that direction? If more passengers or cargoes are shift from road transport to the rail transport or to the buses or to the aviation, then we can conserve lots of energy by implementing new technological innovations. Next is vehicle technology and powertrain improvement. So technological innovations can increase lots of energy efficiency. For example, these internal combustion engines that we use in our cars, motorcycles, trucks, etc., they have loss of energy up to 64 to 75%. And if we improve the quality of these engines, it will save 10 to 25% of energy. Other than that, if we use electric vehicles, and especially if they have regenerative braking system, they can save lots of energy. Low carbon fuels can be replaced with the conventional.
Say that driving an EV requires
About
about
70%
70%
less
less
energy
energy
than a
than a
gasoline
gasoline
vehicle.
vehicle.
So if
So
we
if
do
we
the
do the
whole
whole
life
life
cycle
cycle
analysis.
analysis,
Coming to
coming
the
to the
system
system
level
level
solutions
solutions
and
and urban demand,
urban
urban
design and
design and
demand
demand
management,
management.
if you
If
see
you see
Lahore
Lahore
as an
as an
example,
example,
you
you
see
see
that
that
the
the
Lahore is
Lahore is
expanding to
expanding
its
to its
suburbs,
suburbs.
and there are
And there
lots
are
of
lots of
housing
housing
societies and
societies and
colonies
colonies
are
are
made at the
made at the
suburbs only.
suburbs only.
So
So
every
every
day,
day,
lots of
lots of
people
people
have to
have to
travel
travel
there
there
and
and
have to
have to
come
come
back to their
back to their
workplace, have
workplace,
to
have
travel
to
back
travel
to their
back to
home,
their home,
have to
have to
travel to the
travel to the
hospitals, have
hospitals,
to
have
travel
to
back
travel
to
back
their
to
home,
their home,
etc. and
etc.
etc. So
So
urban
urban
design
design
and
and
policies
policies
can
can
lower
lower
energy
energy
use
use
by
by
cutting
cutting
unnecessary
unnecessary
travel
travel
and
and
promoting
promoting
public
public
transport.
transport.
If
If
cities
cities
promote
promote
transit-oriented
transit-oriented
development, for
development, for
example,
example,
if we
if we
use
use
more of
more of
buses,
buses,
trains,
trains,
trams
trams
compared to the
compared to the
individual
individual
vehicles,
vehicles,
then we are
then we
going
are
to
going to
save
save
lots of
lots of
energy.
energy.
And
And
people
people
don't have
don't
to
have to
travel
travel
unnecessarily
unnecessarily
and
and
contributing to the
contributing to the
energy
energy
losses.
loss.
Policies
Policies
like
like
congestion
congestion
pricing,
pricing,
limited
limited
parking,
parking,
etc.,
etc.,
they can
they can
also
also
enhance
enhance
the
the
save
save
of
of
energy.
energy.
I would
I would
like to
like
give
to
you
give you
example
example
of
of
Paris
Paris
model.
model.
How
How
Paris did
Paris
it.
did it.
Paris
Paris
bring
bring
the
the
concept of
concept of
15
15
minute
minutes.
city. And by
And by
15 minute
15
city,
minutes
we
city, we
mean
mean
that
that
everything is
everything is
accessible
accessible
within
within
15
15
minutes of
minutes of
walking
walking
distance.
distance.
All the
All the
hospitals,
hospitals,
schools,
schools,
communities,
communities,
localities,
localities,
grocery,
grocery,
hospital,
hospitals,
etc.
etc.
Provide
Provide
everything
everything
within the
within the
15
15
minute
minutes
of
of
travel,
travel,
and then
and
we are
then you
going
are
to
going to
save
save
lots of
lots of
unnecessary
unnecessary
travel,
travel,
lots of
lots of
unnecessary
unnecessary
use
use
of
of
vehicles,
vehicles,
and the
and the
health of
health
the
of the
people will
people will
generally
generally
get
get
better.
better.
Freight
Freight
energy
energy
efficiency is
efficiency is
one of the
one of the
neglected
neglected
aspects.
aspects.
So
So
freight
freight
transport
transport
can
can
save
save
major
major
energy
energy
through model shift and logistics optimization. If we optimize our logistics through the innovation of different technologies, then we can save lots of energy. Instead of trucks doing long distance hauling, move more goods by rail or postal shipping, etc., which are approximately 10 times more energy efficient. Digitized logistics tracking, efficient routing, telematics, etc. also reduce empty trips and idling. So that will definitely contribute in the betterment of climate. Digital and operational technology, smart transport we usually call it, is also another aspect that we should look. For example, intelligent transport system technologies, they use the data and improve the communication flow and improve the efficiency of the overall network of the transport. Smart traffic signals, GPS based route optimization, and connected vehicle also help to reduce congestion and idling time to save fuel. In public transport, real time passenger information, for example, when they have to travel, when the next vehicle is available, what is the frequency of the train, etc., and dynamic scheduling improve the reliability and occupancy of the overall system. What we lack right now, because Pakistan have limited financial resources, limited technological resources, so financing and global cooperation is also another aspect. Usually our projects, government projects, are funded by ADB, JICA, UNESCO. Like recently, ADB has funded electric bus systems, metro bus system by JICA, and capacity building by JICA and UNESCO. So we should take more steps to do to share the technological aspects with these. To share the expertise with these institutions, and our stakeholders should do a very effective communication. So rather than taking and hiding their services, we should take technology from them, we should take expertise from them, and then utilize it according to our own scenarios. So these partnerships bring global experience and funding to the local projects. Another aspect is that we don't know actually the metrics, targets, and monitoring. How we should do it. What kind of indicators we should use. There are many indicators that have not developed yet that we can measure to see that how we are approaching, how we are meeting the
global targets, how we are meeting our own targets within our own country. So, in the transport sector, we can check the modal percentage share of the trips by car, different vehicles, by the truck, buses, changes, etc. And then how each passenger of each vehicle is contributing to the environment and the energy consumption. These links directly are linked with the Global Sustainable Development Goals and national goals of poverty. So if we smart city should have or multiple resources, multiple fuels to run the city. For example, we have electric vehicles, but we have supporting infrastructure as well, where the losses, energy losses are minimal. How to deal with the urban flooding? How to address the emergency and disastrous situation? For example, we have recently observed the floods that have hit Lahore and it paralyzed most part of it. So how we need to develop the strategies to have minimum damage from these kind of disruptions and how to enhance the public safety, how to integrate our different modes together to minimize the energy and the overall climatic impact. How European developed that? It is very important to understand. What European did, how they have achieved their goals. They plan ahead of planning. They all sent together their parliaments, their regional, local governments, authorities, all the stakeholders, including public. They set up their directions and they moved in the objectified direction. They included all the stakeholders, including underprivileged communities and people. They integrated technology with energy efficiency and different vehicles, services, and operations. Then they made it safe and accessible and affordable for all of the transport sectors and for all of the people that were going to benefit from them. Then they decoupled economic growth from the fuel source. So if they don't have petrol or diesel, their economic growth is not affected by it. So they are using from windmills, they are using from solar energy, they are using multiple sources. Road safety is the priority in transportation in all aspects. So this was one of the priority and rest all of the things were inclined toward it. Reduce the negative impact of noise and air pollution. So right now in Lahore, you have lots of noise pollution, you have lots of air pollution. So how we are coming? Because we haven't planned it. That how we go for different highly funded huge projects, but how we have to cope with the negative impact. Then finally, multiple fuel sources were explored and included in their legislation, in their law. I will conclude my talk with just a couple of points.
That we need to move ahead towards smart, energy efficient transport. That isn't just one time magic thing, but we have to think in a long term. Rather, a system of optimized modes, clean energy, digital operation, and smart approaches. So it's not just one thing that we have to check. We have to see our legislation, we have to see our people, we have to see our resources, we have to see what is available and how our transportation system is moving. And above all, the land use is very important. By integrating these components, cities and countries can move toward net zero transport where maintaining mobility and economic growth is certain. So that's how I end up my presentation with a note of thanks. Thank you everyone.
थैंक यू डॉक्टर। इससे ट्रांसपोर्ट का कितना वो है परसेंटेज है स्मोक के हवाले से?
स्टडीज हो रही है लेकिन मासिव परसेंटेज क्वांटिफाइड फॉर्म में नहीं क्योंकि इसमें बहुत सारे डिफरेंट फैक्टर्स हैं हाउ वी सेग्रीगेट स्मोक फ्रॉम द अदर पोल्यूशन फॉर्म तो ये अभी पीपल आर वर्किंग सब सर्टेन आंसर
Thank you.
Thank you, Dr. Nizam, for that enlightening session. Now, I would like to invite Dr. Tahir to please join on stage and present the souvenir to Ms. Fiza. Our third invited speaker is Dr. Halil Ibrahim Yavuz, a distinguished researcher in material science and engineering. He earned his PhD in metallurgical and material engineering from Middle East Technical University, Turkey, and pursued postdoctoral research at the University of Cambridge, UK, and ICMS, Spain. Dr. Ibrahim has made remarkable contribution to defense technologies through his research on advanced materials, including protective coatings, lightweight armor, and high-performance composites. He holds 3 commercialized patents and has published extensively with his work cited over 750 times. Please welcome Dr. Halil Ibrahim Yavuz for his talk titled Dicing of Highly Efficient Dye-Sensitized Solar Cell and Sensor Applications.
Dr. Ibrahim, are you audible?
Yes, I am here, and I'm start sharing my presentation also. Are you seeing on the? Are you watching on my screen? Hello.
Dr. Ibrahim, you are visible and audible. Please proceed.
Okay, let me see that. Did you visit? Now you can see me, I think. Hello. Dr. Mohammed, are you there?
Dr. Ibrahim, you are
Yes.
audible. Yeah, we can't see your presentation. Please share the screen.
I shared, but I think you couldn't see. I shared with on the screen again.
Okay.
It's okay. You can hear me.
Yes, please.
Yes, please go ahead.
Please go ahead, Dr. Ibrahim. Yes.
Okay. Let's
Yes,
start.
yes, fine.
Thank you
That's
very
fine.
much
That's
for
fine.
your invitation about this very good the scientific community the meetings. And I am Dr. Halil Ibrahim Yavuz, and I am working with the Tepe University in material science engineering. And we have a lot of projects. Now we continuously follow that. For example, we good relationship with the defense industry and Turkey, and also the outside of Turkey, the big community, for example, NTO, and actually we support from the Newton Fund from England and some support from the Spain.